Hi everyone, in this video we will start section 15.2, which is a double integral over a general region. So what we've seen so far is that we're looking at a rectangular region and how to evaluate the double integral over the rectangular region. However, we can do the same over a general region, and there's a very simple trick we use for that. Suppose I'm interested in this region D, and that's the xy projection of the region that I want to integrate in. I don't have a specific way of doing that. What I'll do is I'll take this region D and I will simply enclose it in a box that's big enough to be a rectangle. And I know how to work with this rectangle because we just learned how to work with the rectangle. And all I'll do is simply define a new function called capital F of xy, which takes the value fxy in D and takes the value 0 otherwise. So what happens is, now as I integrate over these rectangles, every grid that corresponds to a part that is outside is going to contribute 0. So it doesn't really affect, which means we can still use our same process that we have. Now, depending on how this general region is shaped, there are two different types of regions that are formed, and this will seem familiar to you, because when you did areas, you could like orient yourself horizontally or vertically. Remember, so what's the analogy here? It's like, recall if you had like two curves and you're finding the area between them, so you would either go this way, or sometimes you could go left to right, in which case you had to express x in terms of y, so the inverse function. So same thing here. Type 1 is the region D of this form, so you're basically going from some y to y, so you can think of it as a vertical sort of movement here. So it's changing as a y, so y is g2x and g1x. When this is the case, then your double integral f of xy dA, you're going to integrate with respect to y first, because you're moving in the y direction. So you have dy, and as you go, this will be g1x and g2x, and then the y goes from a to b, whatever that a to b is. As opposed to type 2, where the region of this form, which means you're going to have to write your inverse function. So here you're going horizontally. Which means you are going to first evaluate, oh sorry, I forgot a dx here, dx, because it goes from h1 of y to h2 of y, which means that when you end the first integral, you have a bunch of y terms, and then you find the integral with respect to y, which goes from c to d. So what we're saying now is that in this particular case, we have to be careful about the order of x and y, not because the answers are going to differ, but because the integration may or may not be possible in one or the other direction. Let's look at an example. Suppose you are asked to find the double integral of x plus 2y dA, where d is the region bounded by the parabolas y equals 2x squared and y equals 1 plus x squared. So, I mean, before we even get to working what's going on, let me draw two drawings, right? First of all, let me draw in the xy plane what this region looks like. 1 plus x squared is a parabola that does that, which is 1 here, and 2x squared is a slightly steeper parabola that, and the region between them is the following. So this is my integration. This is my region of integration. And if you look at it here, the two curves are present vertically. So that's how I would set up. But even though we do not need the three-dimensional figure, but just to understand what's going on here, so what is really happening is on the xy plane, you have this sort of region, right? This shaded region on the ground. This is gonna be hard to draw. Okay, so you have a 2x squared and a 2 something like that. So this is on the xy plane. So you have this region on the xy plane, and then you have x plus 2y. That's your surface. So that's z equals x plus 2y, which means it's a plane. It's a plane that goes through the origin. Goes through the origin. When x is 0, it's z equals 2y. So it's some plane, right? Some plane going through the origin. And basically what's happening is we're asking, if I project this weird shape up to this, then it's gonna make some sort of a solid like that. And we are trying to find the volume of this weird shaped solid, which is no longer a box kind of figure. And that's what's going on. All right, so once you've identified this region and you've identified the direction, it means we're gonna set this up as x plus 2y, and we're gonna go dy dx. Because now I can write y as, where does it start? It starts at the bottom curve, which is 2x squared, and ends at 1 plus x squared. What about the x value? This will be negative 1 and 1, which you can find by solving these two curves. To get the intersection point, you solve this. You get x squared is 1, or x is plus minus 1. And then you just proceed here with your regular way of solving iterated integral. So x with respect to y becomes xy plus 2y squared over 2. But now the only difference is that the limits, instead of being numbers, are themselves functions of x. So you end up with x times 1 plus x squared minus 2x squared plus 1 plus x squared squared minus 2x squared squared, and a dx for all of that. That's 1 minus x squared, so you get x times 1 minus x squared plus, FOIL it out, you get 1 plus x to the 4 plus 2x squared minus 4x to the 4. FOIL out one more time, you get x minus x cubed plus 1, x to the 4 minus 4x to the 4 becomes negative 3x to the 4, and then a 2x squared dx, which is just a polynomial. So you have x squared over 2, negative 1 to 1, x to the 4 over 4, negative 1 to 1, x, negative 1 to 1, x to the 5 over 5, negative 1 to 1, x cubed over 3, negative 1 to 1. Plugging it in, when you have an even function, this is 0, this is also 0. This will be 1 minus negative 1 is 2, 3/5 again a 2, and a 2/3 again a 2. Taking the LCM, you get 15, so you have 30 minus 5 times 3, 15, and 5 times 4, 20. 50 minus 45, 50 minus 15 is 35 over 15, which is 7 over 3. 6 times 3 is 18, sorry. So this would be 32. This will be 32 over 50. Okay, so that's one way of working on it. Now, let's see, I'm gonna end this video over here, and in the second video we'll go over the remaining parts, which will show us that sometimes you can go in both directions and it should give you the same answer, and it will. And in some occasions you cannot go in both directions. We'll also see where changing the order can really help us. So that's it for this video.